Let me see what I have here. Okay, here we go. Let's try this. So we are going to write recursive equations now. So I would probably do a new page for this. Maybe you don't need to, though. It depends how big you write. Recursive equation. And a recursive equation is one that's based on the previous amount. So in this case, when you write this kind of equation, then like a computer reading this equation, it can just take the previous amount and know what to do with it and keep generating the sequence. So let's write that down. A recursive equation is based on the previous amount, the previous answer, or the previous term, right? The term that came before. Previous means before. And honestly, these recursive equations are the easier ones. I'm going to use the letter N for recursive because I've seen it done that way a lot, like on the SAT and things. So I'm going to use N instead of X's. So let's write down what a few things are going to be in a recursive. F of N, that means the amount now. It's the amount that that you want to find. The number that you want to find or calculate. It's also the output. So if you're not familiar with function notation, when you see this F parentheses anything, it's almost the same as like Y equals. So it's just a fancy way of saying like the answer for term 1 or the answer for term 2 or the answer for term 3. So don't let that like scare you off. Now here's like a new thing. If you want to write the previous term in math language, if you want to write the answer to the previous term, then you write F parentheses N minus 1. F of N minus 1. This is literally translated in math as the previous answer or the previous amount. And it does make sense mathematically, but I just tell people for starters, just kind of memorize F of N minus 1. Just trust me on this. Anytime you see F of N minus 1, it means the previous answer. That's all. And then N is our term number. So term number 1 would be N equals 1. So like, yeah, N equals 1 is the first term. N equals 2 is the second term. You guys still see this? Yeah. So now that we know what recursives are, we need to teach our computer how to write a recursive for a linear equation and a recursive for a geometric or exponential equation. So we're going to do 2 examples here. One is linear, and let's remember that this comes from an arithmetic sequence. And we had one of those, so let's use like 20, 17, 14 as our example. Here's the formula. So this is like a sentence frame. Do you know what sentence frames are? Like when your English teacher wants to make it easier for you to write something, sometimes they give you like a fill in the blank sentence. So this is like your fill in the blank formula. If it's linear and you want a recursive equation, you're always going to write F of N equals the previous amount. That means previous. And then plus, so you're going to write all of this every time. The only thing that changes is what goes in this blank, the rate of change. That's an R. I'll make that nicer. So this is the formula. The amount you're looking for is the previous amount plus the rate of change. So by the way, you're going to memorize this eventually too. There's one more thing you have to put. You always have to put note f of 1 equals whatever. So in this case, you have to indicate what the starting number is. So if we're going to write it for this 2017-14, we're going to write f of n, and we're just going to keep this whole beginning part equals f of n minus 1. And then our rate of change was -3. So I'm just going to write -3. You could write plus -3 if you want. So I just filled in -3 for my rate of change. And then I'm going to write note, this only works if your first term is 20, right? So the computer is going to need to know you need to start with number 20 to make this sequence work. Oh, good. So let's try writing, actually, we'll come back. We'll write another example in a minute. One thing about these formulas is I just like accept it. This is the formula. I'm just going to accept that it works. Because sometimes people are like, I'm confused by the formulas. I'm like, there literally is nothing to be confused about because it's a fill in the blank. Do you guys get what I'm saying? And maybe you're like, I don't know what all those symbols mean. And I think I need you to trust me that at this point, that's not as important as like just knowing how to fill in the blank, because the rest of it comes as we go along. So the other one is for exponential. So you write exponent and then IAL. And remember, that's a geometric sequence. And we can use that same example we were using on the other page, that 324, 192. Oops, you can't see that, sorry. Okay. So the fill in the blank for this one is almost the same. It's f of n, this is the amount you want, equals the previous amount, written like we write it in math, f of n minus 1. And then, of course, it's times the rate of change. And I usually use that dot to mean times. And then again, you have to write note f of 1. You have to tell the computer or me or whoever you're writing for, you have to tell it where it starts. So all we have to do is fill in the blank for the 324, 192. So we're going to write f of n, which means the amount that I want to find. I have to take the previous amount and multiply it by 8. That's it. Oh yeah, and note, this is only going to get you the right string of numbers if you start with the number 3. Because if you don't start with the number 3, you're going to end up with a different string of numbers. Just fill in the blanks. So let's I'll give you 2 of these to try. Let's do, so that's the first one. I'll just call it letter A. And then letter B, let's do, that's not right. Okay, so try those 2. You're going to write a recursive equation for those. Okay, and I know these are a little bit hard to say, but give it your best shot. Jose, can you tell us what you wrote for the first one?
F of n
Yes.
equals f of n minus 1 plus 5.
Good. And then what's the note?
No, f of 1 is equal to negative 6.
Yes. Good. I'm going to zoom in on that. I know I wrote that really tiny. Good job, Jose. So f of n equals f of n minus 1 plus 5. Note f of 1 equals negative 6. Can you give me a thumbs up if you got that? Cool. Great. And then is there anything I can clarify now that you tried that one? Is there anything that like wasn't clear about it? Okay, so then let's do the other one. Can I get Vanessa? Can you do the geometric one or the other one?
F of n equals f of n minus 1 times 7.
Good. And then what's the note?
And the note is f of 1 equals 3.
I think it's 2, isn't it?
2, yeah, 2,
Yeah,
sorry.
yeah. F of 1 equals 2. Yeah, great job. Great. So these, when we do recursives, these are fill in the blank. And honestly, these are the easy ones. So it's just a matter eventually of like memorizing the formula and the notation because it's new. The explicits are a little more involved. So let's go ahead and do explicit now. And these are actually the ones you probably already know, but writing them from scratch writing them from a sequence is a little different. So we're going to say explicit. And by the way, in regular language, explicit means to be exact and to say something directly. So somebody will say, hey, if you talk to Mr. So-and-so, make sure you give him explicit instructions on what to do. That means make sure you're handling every contingency, you're very clear. So what an explicit equation is it tells you what you do to the term number to get the answer. It tells you what to do to the term number, what to do to the term number to get the answer. In other words, the term number is the variable. So if I want term 213, I want to be able to have an equation that says, hey, take the number 213, multiply it by 7, subtract 3. That's going to get you the answer. So this way, if you imagine like going into a computer, instead of having the computer just like produce the string of numbers, the computer could just pick any number it wanted and figure it out for you. So in this case, I'm going to use X's. Really, I could keep using N's, but I think it makes the like memorizing easier if we use X's for these and N's for the other one, though honestly, it doesn't matter. So I'm going to write f of x, that's an x, and that's the amount I want to find, or the output. So this is the answer. That's called the output. X is the term that I'm looking for, and it's the input. So if I want to find term 213, then X is 213. If I want to find the answer for term 213. Okay, so then again, we're going to have two types of explicit equations. We're going to have our linears. And remember, these come from, linear comes from arithmetic. And what's really interesting about this one is that you guys know a lot about it because it's really similar to y equals mx plus b. So if you've studied linear equations before, I'm sure you've come across y equals mx plus b. This is very similar to that. And I'm going to give you the formula, the fill in the blank version, okay? So the fill in the blank version is, I'm just going to write it and not talk for a minute. Okay, so you remember y equals mx plus b? It was the slope that came before the x. So that's our rate of change. That's the same thing as slope. So you're going to write a blank for the rate of change, then times x, plus your initial value. But it has to be term 0. If you remember it with your y-intercept, x has to be 0. So that's where it's really important that we can find term 0. So let's use the one that we had before, which was 20, 17, 14. And if we want to write the equation for this one, we would write f of x equals, and remember our rate of change was -3, so -3x. And then we had to find the initial value by working backwards. So since it's a -3 rate of change, I got to add 3 to get term 0. So plus 23. And then we should be able to check our work. If I want to check my work, I'm going to look for, I don't know, let's look for f of 2. If I did this right, if I input 2 into my computer program, I should get 17 to come out. Okay, so could you try it? Could you check your answer and substitute 2 for x and see if you got the right equation? Yeah, it worked for me, right? So I know I got the right equation. And so if I wanted to put in like 315, I could put in 315 and I would know what the 315th number of this pattern is, okay? So this is your fill in the blank for that. Notice what's interesting here is that the initial value, which is so weird because it's like the starting point, but it comes at the end of the equation. Because what we're about to see is that in our exponential equations, it's backwards. So that was linear. And so now let's do exponential explicit. This is our last one. Actually, I'll have you do a couple examples, but the last one that we have to do, geometric. And I'll write the frame again, the formula. Okay, so for exponential, you start with the initial value. And then look, these two are very similar. Linear was rate of change times x. Exponential is rate of change with x as the exponent. Get it? Exponential. Oh, I didn't even spell it right. Exponential. Exponential, x is the exponent. So if we use that one we used before, we had 324, 192. But fill in the blank. The initial value, remember, like if we're multiplying by 8, we would have to divide by 8 right here. So my initial value, if I had a term 0, it would be 3 over 8, right? 3 divided by 8 because I worked backwards. So that's my term 0. And then my rate of change is times 8. And I put an x for the exponent. Okay, let's try these because these are a little trickier. So I'm going to give you 2 examples here. So here's example A. And then example B. Okay, so try those 2. I switched it up, did you notice? I'm going to give us maybe 30 more seconds, and it's okay if you're not quite done in 30 seconds. I just want to make sure like we finish on time, maybe even a couple minutes early because this has been a lot of writing. So take about another 30 seconds. Daisy, for the first one, was it linear or exponential?
Linear.
What was your rate of change?
Times 2.
That makes it exponential, right? Because it was a multiply rate of change. That's okay. So did you use the exponential formula though?
Yeah.
Okay, so what do I put first?
F of n equals f of n minus 1 times 2.
But we're doing the explicit ones now. So what you just did was good. You did the recursive one from the previous page, but let's fill it in using this other kind, the explicit. So you already told me that the rate of change is times 2. Oh, you guys can't see what I'm writing, can you? Let me put that here. So we know that it's blank times 2 to the exponent of x. And we'd have to figure out the initial value or the 0 term. So term 1 is 12. So in that case, what would, Drew, what would term 0 be, or the initial value, Drew?
6.
Beautiful. 6, yeah. And this one's kind of easy to check. Like if you wanted to check f of 2, you could say 6 times 2 to the power of 2. 6 times 4 is 24. Works out fine. All right, so then the other one, this one was our linear one. And what did you write for this one, Jesus?
I didn't finish.
Okay. Is it linear or exponential?
Linear.
Good. And can you tell what the rate of change is by looking at it?
+6.
Yeah, exactly. So the linear one, it's like the rate of change times x. So we can just put 6x because like that's the slope, right? And then the zero term, we'd have to subtract 6 from the 2. So we'd actually get plus -8, or you could just write -8. And if you look at term 2, it works because 6 times 2 is 12 minus 8 would get you 4. Term 3, 6 times 3 is 18 minus 8 gets you 10. Okay, so what I would like you to do for your homework, and I haven't posted it yet because I had to change it from what I originally thought, is that patterns thing is I'm going to have you go back to that patterns assignment and use Cami still. And I would like you to type for each one the explicit and the recursive equation for each one. And just do the best you can. I'm going to ask for it to be turned in by 12 noon on Sunday. So hopefully you'll do it today or you'll do it tomorrow. And the reason I want them by like 12 noon on Sunday is so that I can look them over before class on Monday. So I have an idea how well everybody did. Okay, so I'm going to post all that so you have the instructions on Google Classroom, but you're just going to do it. You know how it was our first assignment? You're just going to turn it in for the first assignment. Remember how we never turned it in? So once you get the equations in, that's when you're going to hit like turn in or submit. Does that make sense? And if the other work you did somehow got lost or something, it's okay. Just put the equations on, okay? You don't have to start over or anything if the work from last week got lost on it. Thank you so much. I promise class is not usually like this. It's not going to be like a freaking over an hour of taking notes. But honestly, we just finished chapter 1. So that's amazing. You guys, thank you for hanging in there with me. And on Monday, you're going to have a lot of time to work out problems with each other. And it won't be like lecture like this. All right. Have a great weekend.